Hello guys, in today's video we are going to solve LeetCode question number 2264, which is largest three same digit number in a string. You are given a string num representing a large integer. An integer is good if it meets the following conditions. It is a substring of num with length 3. It consists of only one unique digit. Return the maximum good integer as a string or an empty string if no such integers exist. Note, a substring is a contiguous sequence of characters within a string. There may be leading zeros in num or a good integer. So, in this problem, we have to find a unique maximum digit which repeats exactly 3 times in a contiguous manner. So let us take an example which will help us to identify the solution for this problem. We need to find the substring of length 3 which has the maximum repeating digit in it. So if we go through this string, we can see that okay, 7 is repeating exactly 3 times here. So this is one of the possible solution. If we move ahead, we can see that okay, 3 is again repeating here exactly 3 times. So we can say that this is also one of the possible solutions over here. And over here we can also see that it is also again repeating 3 times. 3 is again repeating 3 times. So this is also possible solutions. So the solutions possible are 7, 7, 7, 3, 3, 3, 3, 3, and 3. So these are the possible solutions or the possible substrings from this given integer. But we need to find the maximum digit repeating 3 times. So if we check all these three substrings which are possible solutions, 777 is the highest digit repeating 3 times. So this is our solution. Okay, so one other thing we need to actually look for this problem is that we need to calculate what are the possible solutions that can happen. For example, in given any string, the possible solutions are going to be digits from 0 to 9 repeating at most 3 times. What do you mean by that? Let me explain. Let it be any given string. The possible solution is always going to be either 9, 9, 9, 8, 8, 8, 7, 7, 7, 6, 6, 6, 5, 5, 5, 4, 4, and 4, 3, 3, 3, 2, 2, 2, 1, 1, and 1, and at last 0, 0, and 0. So these are the only possible digits or the substrings which can be there. So for example, what we'll be doing is these are the only possible valid or we can say good substrings that can be solutions. So what we can do is we can check one by one starting from the 999 to 000. We can check which string or which substring is present within a number. So we can go like, okay, we need to check. Let us take as we want to find the maximum number. So we'll start from the highest, that is 999. We'll check, is 99 present anywhere? No. So we go on to the next string, which is 888. Is 8888 present over here? No. So we'll move on to next, 777. So is 777 present over here? Yes. This is the maximum substring or the maximum good string that we can find. So we'll return this. So for example, in other case, suppose there is no such string in this given question or given input. For example, let us take 1, 2, 3, 4, 5, 6, and 7. Okay, then we'll again move through all of these numbers. We'll check, is 999 present over here? No. Is 888 present over here? No. If 777 is present over here? No. If 666 is present over here? No. Is 555 present over here? No. Is 444 present over here? No. Is 333 present in the over here? No. Is 222 present over here? No. Is 111 present over here? No. And again, if 000 is present over here? No. So the given string does not have any of the possible substrings. It means that if we iterate through this entire possible set of solutions and if we don't find any particular solution for this string, it means that there is not solution to this question. There does not exist a substring which has three digits contiguously repeating. So in such case, we'll return an empty string. That's it. We'll iterate, go one by one all through this. We'll go one by one over all these possible solutions. We'll check if any of the solution exists over here. If it not, then we'll simply return an empty string. Now let us begin with the implementation of our logic. So first we need to declare an array of strings which will contain all the possible solutions or all the possible good strings for any given string. So yeah, this will be an array of strings. So it will have all the digits repeating 3 times: 999, 888, 777, 666, 555, 444, 333, 222, 111, and 000. So now we'll iterate through all of these possible strings and check if any one of these string is present in the integer string num. So we'll go iterate through for loop. Sorry, int str. Here we will be performing a naive search which to find whether this particular string is present in the num or not. So we'll go through nums. We'll check if num dot index of str. So the index of method is a method of string class which performs a naive search and returns the starting index of the given substring in a string. So it will first check if 999 is present in num. If present, it will return the starting index of the substring, or else it will give -1. If it is -1, it means that that string is not present, that substring is not present in the given string. So if we'll check if it is not equal to -1, then we'll return. It means that if it is not equal to -1, it means that we have found the string. So we'll return str, which is the solution. So it will iterate through all of the numbers, all of the substrings until we found one. So if it matches, it will return the string which is matched. Else if it does not find any of the possible solutions, any of the possible substrings in the given nums string, then we'll return an empty string as mentioned in the question. So let us try and run this code. Yeah, so we'll try to submit it. Yes, you can see it is accepted. Now coming to the time and space complexity of this code. So here we are declaring an array of strings which is of size 10. So for any given input of string num, it is going to be constant space because it is not going to increase, because the possible set of solutions are always going to be 10. So the space complexity will be big O of 1. Now coming to time complexity. So here we are performing a naive search. So what does naive search means? It will check character one by one. So it will check 9 one by one with each of the strings character. If found, then it will check for uh, next character in the given solution. Will search is again a 9 coming after a 9. Yes, then it will again check. If no, then it will continue. So the time complexity is of the naive search is O of n into m, but here it will be, as the length of the string is only 3, so it will be O of n into 3, which will be equal to O of n. Okay, and again we are if we calculate the time complexity of this entire loop, so it is going 10 times, so it will be O of 10 into n, which is equal to O of n. So the time complexity will be O of n. Now let us try to find an optimal solution for the given problem. So naive search is an expensive operation. It takes almost 3n time or O of n time to find whether the particular string is a part or is present in the given num string. So instead of performing naive search, we need to do something else to figure out whether a valid substring is present in the given nums string. So as we know that the solution or the any valid substring is only of length 3. Okay, so it is not going to be of length 2 or less than 3 or more than 3. It is always going to be exactly of num 3, length 3, and it is going to be contiguous. It is not going to be like that. It is going to be a non-contiguous sequence. So we need to find numbers which are unique, repeating exactly 3 times, digits which are repeating contiguously exactly 3 times. Doesn't this sound familiar to something or any kind of pattern? Exactly. As we can see that we need to find contiguous substring, and when any problem mentions that it is going to have a contiguous substring, we should definitely go for a sliding window approach. So what we can do is, we know it is the length of the substring is always going to be of 3 size. So what we can do is we can create a sliding window of 3. So let us start from here. We'll check. Okay, so is it having all 3 elements as 6? No. So we'll move it further. We'll take it over here. Does the substring having all the digits as same as 7? Yes. So this is one of the solution. We'll check again for this. No. This. No. This one. No. Then this. Yes. So again 333 is a possible solution. Then we'll check. Okay, this. Yes, again this. So by sliding a window of size 3 over the entire string, we can find out whether a digit is repeating exactly 3 times. So if a window is consisting all the characters or all the digits as same, then it is one of the possible solutions, and we need to check whether if it is maximum. For example, initially we found 777, so it is the maximum. So initially 7 will be set as to the maximum. Then as we go towards this window, it is again having 3 repeated 3 times. But is 3 greater than 3? No. Again similarly, 3 this window. This window is also having all digits as 3. Is 3 greater than 7? No. And at the end, we need to check if, for example, initially we'll take an empty character, which means that initially we haven't found any valid string, and if we find one, we'll compare. Okay, blank space is always going to be bigger than 7, so it will be set to 7. Then again 3, no, 3 is not greater than 3, 3 is not greater than 7, so only 7 will remain as same, and so on. If there is no possible solution, no possible consecutively 3 times repeating digit, then this blank space will remain as same. We'll check if it is the max is only blank space, it means that we don't have the solution for this given string, and we'll return an empty string. So now guys, let us begin implementing our optimal approach. So initially we need to keep a track of max digit, which is repeating exactly 3 times. So we'll only keep track of a single digit which is repeating at most 3 times, and while returning it we'll concatenate it 3 times. So we'll keep a track of that by using a character variable which will be max, and it will be initially stored as an empty or blank space over here, blank character, which will represent that we haven't found any solution to this. After that, we'll move on iterating the window through the entire nums string. So we'll move the sliding window over the entire nums string. So we'll simply use a for loop for this. Then I will be less than equal to nums dot length minus 3. We are doing minus 3 here because the length of the window is exactly 3, so we don't want to go out of bounds, so we are minusing it or reducing it by subtracting it by minus 3. Then we'll find all the characters in the window. So we'll find the first character in a window, which will be nums dot caret I. Then we'll find out the next character, nums dot, it is num, I plus 1. Char c3 will point to the third or store the third character in the window, which will be I plus 2. So c1, c2, c3 are all the characters within the sliding window. Now we need to check if all are the same or not. If all are same, if c1 is equal to c2 and c2 is equal to c3, it means that all the digits are same. Now if all the digits are same, we have found one of the possible solution. Now we need to check whether it is the maximum or not. So we'll compare max is equal to whether it is greater than max. We need to only store it or track it if it is only maximum than max or greater than max. So we'll compare if c1 is greater than max, then we'll store c1 into max, else max will remain as it is. Okay. After we come out of this loop over here, we need to return the solution. But what if we haven't found any solution? For example, if there exists no such possible good string in the num string, so the max will be empty character or blank character itself. So we need to check that if max is equal to a blank character, it means that we need to return an empty string representing that there is no possible solution or no such good string present in the num string. Else what we can do is, if it is not blank character, it means that there is a solution or there is a good string in the given num string. So we need to repeat it 3 times, as we have only calculated it once, or keep a track of one digit. We'll repeat it 3 times. Max, we'll concatenate it 3 times. Yeah, that's it. This will work. Yes, it is working, and now let us submit it. Yes. So now let us calculate the time and space complexity of our code. So space complexity. Here we are not using any kind of extra space, so it is going to be a big O of 1. Now in terms of time complexity, it will be big O of n, and it is a single pass solution. So we are not iterating it multiple times, or we are not performing naive search. We are only iterating the entire nums or num string exactly once. We are not performing any naive search, which is better than the previous approach. And you guys might be thinking that, okay, this is 8 millisecond solution, and the naive solution or the naive search solution was 0 millisecond. The reason behind this is, it is because of Java. The index of method of Java is really optimized for these kind of things, and it is performing well, particularly in Java, and that's why it is giving it as a better solution. But if we compare it in terms of uh, time complexities, big O notations, this is a better solution as compared to the naive search algorithm. That's it. Thank you guys.